And here we are for part 2 of the practice with exponential models. Here we go, here we go. Consider the amount of money in the account shown in the graph to the right. Estimate the growth factor. Now, first things first, we know it's growth because our graph is going up, left to right. So to find the growth factor, we take 2 consecutive points, and it doesn't matter which 2. Anywhere on the graph, take 2, and we're going to divide new divided by the old. So the y values, new divided by old, and we're going to get roughly 1.15. So that's what would go inside the parentheses. So that means the 0.15 part, as a percent, we have a 15% increase here. And if this is a savings account, I want that kind of account right here. All right, so let's construct a model for every year since 2010. So y equals, what's my initial amount? Well, we start at 250. We know our growth factor is 1.15, and we raise that to the x. Now that I have my model, we can predict the value in 2018. Let's come back here and look at this. So when x is 0, I have 250, okay, because it's years since 2010. So x is 0 in 2010. So that means in 2018, what is my value? And x equals 8. So if I plug this in, so y equals 250 times 1.15 raised to the 8th power. We substitute and we simplify and we get 764.76. Now, right now, if you're thinking, stop, wait, why don't we just plug in 2018? That's what's down here. Okay, if that's your initial thought, okay, it's not a horrible thought at all. But if you do this, if you type in 1.15 raised to the 2018 power, my calculator legit says error, overflow. That means the number is so big, we can't even do anything there. That's how big it is, okay? So when you do that, or when you get an answer that is just huge, if you think about where this is going, for 2018, we should be somewhere around, 700-800 based off this graphic. So make sure, I've said this before, and I'll say it again, don't let your common sense leave you. So if you're like, okay, this process is what I think I should do, and then you get some ridiculous answer, scrap it and try something else, okay? So our answer for the first one, 764.76. Now let's use guess and check to predict when the account will have over 1,000. So now we're trying to figure out when is y going to be 1,000. Well, we know it's bigger than 8, right? Because 8, when x is 8, y yields 764.76. We found that up top. So let's guess something bigger than that. I don't know. How about 10? When I type in 10 into the exponent and simplify, I get 1,011.39. Okay, that's good. That's above. Is that the most? I'm a big fan. You want one below and one above so that you know. When I substitute in 9, I get 879. So 9 is too low, 10 is slightly too high. So we're looking at somewhere between 9 and 10 years. If they want an actual, like, when will you have over 1,000? It would be 10 years. All right, let's do one more of these. Most cars decrease in value as soon as you drive off the lot. However, some cars are considered classics and increase in value over time. Imagine you have the choice of owning one of 2 cars. A new Mazda Miata. It's $23,000. It depreciates 10% a year. Or you can have a classic 1970 Ford Mustang, $12,000, and it increases at 6% per year. Let's write equations, which represent the value of each of the cars. All right, so first we're going to have the Mazda. Notice we have percentages, so they're exponential. So y equals, how much is the Mazda originally? The initial amount is $23,000. Then I go 1 depreciates, so we're subtracting 10% inside. So I have y equals 23,000 times 0.9 to the x. Great. Let's go to the Ford. So I'm going to have y equals, what's the initial amount? 12,000. 1 plus, because it's increasing, 6% of 0.06. Simplify inside, and we have y equals 12,000 times 1.06 to the x. Now, part B says use each equation to estimate the value of each car for the next 6 years. So you're going to go through and you're going to substitute in 1, 2, 3, 4, 5, 6 into the equation and complete the table. So let's go ahead and do that. Oh, or if you let's do the Mazda together. If you plug in 1 for the Mazda, you end up with 20,700. You could, from there, just take that and multiply by 0.9. Because every time, if you multiply by 0.9, you get 18,630. And then you could multiply by 0.9 and get 16,767. Because it's every year you have that 0.9 piece. Okay, finish the table for both of these. All right, so you fill in. I rounded each of these to the nearest penny. But you have your side-by-side table, Mazda versus Ford, where your Mazda is decreasing every year and the Ford is increasing every year. All right, that's what happens with classics. So our last question is, when does the Ford overtake the Mazda? So wrong button. So we're doing kind of a comparison, right? Side-by-side comparison. Year 1, the Mazda is greater, so that doesn't work. Year 2, the Mazda is greater. Year 3, the Mazda is greater. Year 4, the Ford is great. Not by much, right? But about $60 worth. But that's when it is. Year 4. So after 4 years, that Ford's going to be worth more. Now, there are other factors that go into this. So if you're driving that classic car 80,000 miles, right? More miles you put on, that also decreases the value. But just in general, kind of looking at this, this is where we are. So I hope that, I hope that was fun for you.